I'm in a strange position that I've written now two books on chaos engineering, but I'm going to talk a little bit about something else. So I'm going to start with a story, and I didn't expect to share this story with you whilst one of the participants in this story was also here. So Grant, I can't see you on the screen yet, but I apologize in advance. I'll try not to mention your name. Anyway, I'll start with some fool managed to, no, it wasn't, it's not. We have a story, we had a problem about half a year ago. Now, if you're not familiar with me much at all yet, I'm a CEO. And as a CEO, I worry about certain things. And one of the things I really worry about is upsetting my people inside the company and upsetting my people that use the systems we provide. And in the course of last year, we managed to do both. We managed to upset anyone using the system, and we managed to upset certainly ourselves. What happened is our CTO decided to do the one thing a CTO should never do. He decided to go on holiday, vacation for those in America, and he decided to leave and in a strong belief that everyone in the team knew what to do should something go wrong. Also, he had seen that in the last few months and weeks, not much had changed, therefore not much had gone wrong. And if you're not familiar with Murphy's Law, I would argue that most of the work I've done over probably the last 2 or 3 years of my life has been in the service of understanding and overcoming Murphy's Law. And Murphy's Law was 100% in effect at that moment when my CTO decided to go on vacation. Because literally an hour after he had disconnected and walked out the office, everything died. And it died spectacularly. Everything died on our side, their side, every possible which way but loose. And the first we knew of this was that our websites went down. And then also so did our systems, our consoles, all the tools we provide. And I should point out here, we're a company that provides tooling for practicing reliability. So you could argue this was the most embarrassing thing to happen to a system that's supposed to be helping you become more reliable, to demonstrate that we were not reliable. So at the end of that escapade, I think Grant, who's here, the rest of the team as well, we'd all aged by about 20 years. And at the end of the weekend, we were sitting there going, wow, we never want that to happen again. And I think most people have experienced this. Most people have had an outage or an incident where they've got to the end of it and gone, we never want that to happen again. And you can even get more general in this case. You can look at the sorts of things that are happening in the world right now and say, many of us are going, we need to be better prepared for this in the future. But where do you start? This is the problem we face. What's the first thing you do? What do you prioritize? Once the crisis is over, what do you learn from? What do you do better? So that's what we exist to help people do. And this is the journey we went on in order to figure out how we could be better. And essentially, it's at the heart of everything we do now with our product. Okay, so it came back to that question, what should we do to be better? And the first thing is, how do we know that we are better? What does better mean? Well, for us, we use the sort of several terms that we use very blurrily. And I think most people do use these terms blurrily, not just Naringa trying to pronounce them. Many of us use these terms, use these terms very blurrily, right? We say things like, we want to be more reliable. We want to be more robust. We want to be more resilient without really ever knowing what those things mean. And I see this over and over again in literature and online and on Twitter and everywhere else, where people are using these terms without necessarily understanding that they are fundamentally different. And there are some relationships between them. So I'm going to unpack them. I'm going to try and make this not boring for you, but I'm going to unpack these. I'm going to define them. So we take that sentence. How do you know you're reliable, robust, or resilient? Okay, let's start with the first word, you. How do you know? Who is you? What does you mean in this context? So one of the things I want to remind everyone is that when you're deciding whether something is reliable, robust, or resilient, the you in this equation is everything. It's the people, the practices, the processes, the technologies, the cloud platforms, everything you've thrown money at to buy. You've got your CI/CD pipelines, your developer tools, everything. The phrase you'll hear used for it is the socio-technical system. I find that a bit redundant. All systems are pretty much socio-technical. There's usually a human element, that even if it's on the periphery, somebody's involved. And so essentially it's the system. In the rest of this talk, I'm going to talk about it as the system. So that is you, the system. And that includes the customers, the users, everything that surrounds it. Because it's only when you grip the whole problem that you have a chance of actually improving things like reliability, resilience, and robustness. Okay, so that's you. It's everything. Hope that clarified it. The second definition here is that word no. Now, I get this a lot. I get a lot of people coming out to me going, Russ, I know my system is reliable. Fair enough. That's brilliant. If you do, wow, well done. I also get a lot of people coming up to me going, we spent a lot of money on our database. We know it's reliable. It's like, great. I don't know how you could know this, but before we worry about that, let's talk about the word no. You see, when you dig a little deeper into it, you find out that word no rarely means the sort of scientific, rigorous knowledge that it's supposed to mean. What they're actually saying is something else. I'll give you a concrete example. I spoke to an Amazon engineer over in Seattle, and I was talking about chaos engineering experiments. We'll talk about those in a minute. And I said, you know, you might use these things to see how your system responds to a certain set of conditions. And this gentleman turned around quite honestly and said, look, I don't need to do this for my database. I know my system will die if my database dies. I was like, fair enough. Do you know that? He's like, yes. And I said, have you seen that? Said, no. Have you ever experienced it in any sense? No. Are there stories of what happens when it dies that, you know, written down somewhere? Maybe you call them post-mortems, incident analysis, whatever you've got. No. So what you've got actually is a strong suspicion, possibly a strong hypothesis that if your database dies, your system will die. But what you don't know is how it will die. You don't know what the effect on that system, that socio-technical system, might be. What about if other parts of your world have decided to introduce little strategies like circuit breakers? What happens to those if you die? You just know in your limited view, your limited perspective of the world, that if your database dies, well, your world's over. But you don't know the impact on the greater world. And so we have to be very careful. In English, we often use the word no when we mean I strongly believe or I strongly suspect. So we don't know. And that's the mindset change I want you to think of first. We don't know what will happen to our systems. Our systems are usually sufficiently complex, especially when you factor in people, to go, I don't know what will happen. Until it happens, I don't know. And that goes back to my story of my team. Now, my team's only 5 people, including me. And we didn't know how we would respond to something going wrong. We didn't know how we'd detect it. We didn't know who would see it first. We didn't know what system might flag it up. We didn't know what to do about it. We didn't know how to debug it. There were all sorts of things we didn't know. But if you'd asked any of us before the event, did we know the system was reliable? We'd have probably said yes. Okay, so no is a dangerous word. And I'd like you to take the mindset switch of we're going to actually think of no as something we need to prove a lot. Okay, so definition number 3, that word finally, reliable. What does it mean? What does it mean when you say your system is reliable? What does it mean to anybody else? Well, the first thing to know about reliability is it's best measured from the consumer of your system. It's best sensed from them. A reliable system doesn't mean that it's available all the time or it never breaks internally. It means that the expectations of the consumer are being met, and ideally being met very satisfactorily, very well. In fact, the phrase we like to use in reliability is You're making the users happy. Happiness is something you can measure, and it is something you can see. When someone has the trust and confidence in your system to say, I rely on it, then you have reliability. Factors that attack reliability are things such as availability. Is it there when I need it? Also, is it secure? Does it manage to leak my information out into the world? In fact, what we're saying here is what tends to ruin reliability is surprises. Unpleasant surprises ruin reliability. Okay. That's reliability. Let's look at one of the more complicated ones. Not to pronounce, I should point out, but certainly a more complicated issue. Robustness. I hear a lot of people say that their systems are resilient. I've introduced circuit breakers, or I've got an HA database, or I'm running on Kubernetes. Therefore, I am resilient. It's a resilient system. And I always slightly die inside when I hear it that way, because actually it's not. It's a robust system. So let's be careful about this definition. Robust means that it can handle things you designed it to handle. You sat down and said, this can happen, and you've applied strategies to make sure it can handle those things. That's great, don't get me wrong, that's really powerful and important, but that isn't resilience. It's robustness, and that's why you'll often hear people say that robustness is a technical challenge. But for me, robustness is an expectation challenge, it's a knowledge challenge. Robustness is for what you know. Now that unfortunately leaves a huge gamut of things that cost us a lot of money and affect the reliability of our system. Because there's the things we know, and there's the things we don't know. And if we go back to my story from the beginning, what happened to our system to cause it catastrophically fail was something we did not see coming. We never anticipated it. We thought our processes were pretty good at managing these things, and we knew that. So we'd actually got good testing, good performance testing, good penetration testing. We'd done all the right things. We bought all the right stuff. And yet still, we were vulnerable. And we're vulnerable. We're all vulnerable. All our systems are vulnerable. Any robust system is vulnerable to surprises. Okay, so let's go to the last word in this mix, which is resilience. Resilience is your system's ability to handle and learn from surprises. When something happens you didn't anticipate, how does your system respond? How does it anticipate something surprising coming? How does it synchronize and coordinate around that thing that's going to happen? How does it then respond? So resilience has got almost nothing to do with technical response mechanisms as such. It might leverage them, it might be helpful, or they may be incredibly painful to your abilities to anticipate, synchronize, and respond. And this is an interesting point. You could do everything right as far as you're concerned. You could build a fantastic, extremely expensive, glorious observability system. You could build a gorgeous, to the level of Jez Humble thinking you're wonderful, CI/CD DevOps style pipeline, automated to the hilt. You could do everything right with unit testing, integration testing, system testing, functional testing, the lot. And all of that is good. But when you bring it all together in a moment, when there's a failure in production, do those things provide a net positive or a net negative to your outcomes? And that's the challenge that resilience engineering is all about. How do you, when you bring this dream team that you've designed together, how does it actually play the game? And the truth is, you can have fantastic, for example, observability. You followed everything Charity Majors has ever said, and you put it all into place. And there's a good chance it'll help when something goes wrong. But there's also a danger, even if you followed all that great advice, that it still ends up playing out poorly in your context when it plays with others. So when we talk about resilience engineering, we're talking about exploring surprises to see how our system anticipates, synchronizes, and responds to these scenarios, these circumstances. Okay. And in fact, we go further. We define it just a little more. We say you're developing something in your system, something you don't develop any other way. You're developing the capacity to adapt. That's what you're looking at. A resilient system is able to adapt to surprises. And this means that it is invested in its ability to anticipate, synchronize, coordinate, respond. And the last piece that people forget is proactively learn about these things as well. Proactively learning is key because don't get me wrong, it's great to learn from a crisis. If your system goes down like ours did, learning from it is a good idea. Incident analysis, good idea. And there are great tools for learning from these things. However, learning at that moment is probably the most expensive option you've ever done. By then you have potentially reputational harm. You also have a team that have gone through hell. I can say with some confidence that I think everybody in our team hated every moment of that outage. The thing here is you don't have to wait till the crisis to do the learning. In fact, you shouldn't. You should do something else. And this is what resilience engineering is all about. Proactive learning to improve your anticipation, synchronizing coordination, and response. Okay, so how does this all relate to wonderful things like chaos engineering? Well, before we get there, let's talk about the key thing that you need to recognize to do this. I'll give you a negative to help you understand it. You can't buy reliability. You just can't. You can't go to the shops and go, I'll have a reliable system today, please, as opposed to something else. You could spend a lot of money on lots of things that when they come together will not work well. Now, I'm English, as you probably detected from my terrible accent. I'm English. And as an Englishman, I occasionally watch a stupid game where they kick a ball around a field. And in this sport, we are known to have invented this ridiculous activity, right? Okay. The English football side, the football team of our nation, is a perfect example of what your system could go like. You could spend all the money on all the best players in the world and you put them together and they can't play for toffee. They are terrible together. And what do you do? If you're a coach, if you're the manager of the England football side, as let's be honest, it's very rarely an Englishman these days, it's usually a highly qualified foreign individual, which is a great thing. You're brought in, you've got to handle the job. What do? You try and bring them together and you practice. You practice together. You only know how good you are when you practice together. You only know where your surprises, your weaknesses are when you practice together. You have practice matches. You get people to run drills with other people that they've not played with before. You get the team to develop. Every system, every socio-technical system is the same. When it encounters match day, when something's going wrong, how practiced you are is the difference between you doing well and you doing very poorly. Doesn't matter what you bought, it's how practiced you are. So let's go back to that. So we deliberately practice this. Resilience engineering, reliability is a deliberate practice. You will proactively practice these sorts of scenarios alongside your regular development work, and you will see this is something that everybody does. And there are multiple tools you can use to practice. Just like I mentioned before, where you can do whole practice matches, you can do drills against the wall or just with a couple of players. The same things exist in the reliability toolkit that you can develop in order to practice and develop your resilience engineering capacities. So those practices in the toolkit, those tools in the toolkit, are things such as chaos engineering, verifications, and game days. Let's start with the lowest rung, chaos engineering experiments. Chaos engineering experiments give you one insight and one insight alone. Does anything surprise me when this happens? So with a chaos engineering experiment, you'll say, this is what I technically think should occur. This is my hypothesis. I'm going to now do those things to my system. I'm going to set up this drill, if you like, and I'm going to see if my system survives the way I expect it to. That's what a chaos engineering experiment does. It can't tell you much more because it's not aware of much else, but it can help you discover surprises. Chaos engineering, and in fact, all of these tools are surprise hunting approaches. So you interpret what happened in the chaos experiment, and it's in that interpretation and communication of what happened that helps you figure out what surprised you and gives you an opportunity to potentially prevent outages, but also, more importantly, to practice how you respond, to see how the system technically responds. Verifications extend chaos experiments just a notch. They introduce the concept of an objective. And what that means is you can say, this thing's important to me, it's something I can measure. If you're practicing SRE, this will be very familiar. If you're using a service level objective and service level indicators, you're most of the way there. If you've got those two things that you can measure and those two things to work towards, then what a verification will do for you is it will tell you what the impact on that objective was when these conditions happened. So this is slightly broader. With a chaos experiment, we could just say, I think this is how it will work, and am I surprised? With a verification, I can say, this is what is important to me, and this is the impact on it when this set of conditions occurs. Verifications are much more powerful, even though they're a small technical step, much more powerful because you can take that story to everyone in the business and go, we care about this, right? This objective is important to us. Yeah, I've seen if this happens, I've seen this impact on it. Wouldn't we rather look at how we deal with this and be better at it before it happens in the wild, before it happens in production? So verifications are extremely powerful because they add the concept of business value of objectives. Last but never, ever least is the wonderful, powerful technique of a game day. If you haven't run a game day, you have an absolute treat ahead of you if you ever do this. A game day is, and the best analogy I've got is it's a bit like Dungeons and Dragons, but you get to play it at work. What you do is you set up a scenario, a circumstance where your team are going to inhabit a moment where within usually 3 hours, something's going to happen, and you're going to observe how they anticipate, synchronize, coordinate, and respond. The beautiful thing about a game day is it brings all the threads together. It's like a match day practice. It's the perfect way of really seeing what is going to go down. The downside of it is it's expensive in time and people's effort. It's a big exercise, even if you're doing a very small thing. And so you usually do it for the most valuable things to explore, where maybe you're going to explore multiple different conditions over a course of 3 hours. But it by far is one of the most powerful proactive tools in your reliability toolkit. Okay, so those are the three main ones, but they all exist to give you one answer. And that is, how good are we at handling and learning from when things might go wrong? And all the three of those tools are proactive learning tools. So you want to bring all of those to bear. And the best organizations I meet are, we have customers that are extremely diverse. We've got people who are working on mainframe systems right through up to your cloud-based systems, Kubernetes, Lambda, functions as service. The truth is, it doesn't matter what your technical stack. You don't know how reliable it is. You don't know how resilient you are until you practice it. And it's not a tax. This is not something you have to look at and go, oh my goodness, we have something else to do now. This is something the best of us have been doing anyway. When you use a system that you rely on, I can almost guarantee that they at least have some of these things. They might not call these things, they might not call them verifications, they might not call them chaos experiments, but they have the mindset that knows that they need to invest in their anticipation, synchronizing coordination, and response. The best organizations are going to have a touch of resilience engineering in there. Okay, so that's most of what I wanted to share with you today. I don't know if I've gone over time, under time, left of time, or right of time, but hopefully I've left loads of time for questions. I guess one of the things I want to leave you with as a last closing point is this is something you can do today. You don't need any specific technical tools to do this. Now, that might seem like an odd thing for me to say, considering my company create tools that help you do this, but you don't need them straight away. You could do any of these things I've mentioned with a bash script and a bit of care. You can explore weaknesses in your systems tomorrow. In fact, you could do it tonight. I would recommend you don't do it in production first. Don't be that company that phoned me up and said, we ran Chaos Monkey in production and we learned lots of things like never to do that again. That's not the lesson. The lesson is one of how did we handle this and how could we be better? The key thing, in fact, this is the last thing I'll leave you with. The key output of all of these techniques, all of these tools, is learning for everyone. It's helping everyone see where the surprises were. And so there's a great quote I've heard from John Allspore on this, where he said, one of the best outcomes you can measure for ROI of doing these things is when you distribute the analysis of what happened when you did an experiment or a verification or a game day. It's how many people read it. That's the measure of success. How many people cared? How many people did you engage? Because it's all about how the whole organization learns from these things. That's where the real ROI of resilience actually is. I think that's everything now. I should always point out, and I'll do this as my little advertising thing, there are books out there. Don't worry about that. For the best question that I get in a minute, I will find a way to get you a copy of these books, both of them. And I will send them through. Hope you enjoy them when you get them. I should point out they're not inconsiderably expensive. So I shall happily send them to you. Hopefully someone will ask a question from a place that Amazon can deliver to. That would be perfect for me. But either way, I'll probably let Neringa and the team decide who wins it, just to up the ante on them, add a bit pressure for them. And but either way, whatever they decide, I shall get you copies. Whoever's got the best question will get a copy of both of those books in the post somehow, some way. And that's all I have to leave you with. Thank you very much, Neringa and the team, for inviting me to chat to you all.
Hey, Russ, thank you so much. So do we have that question? Morten, I see you want to say something.
Morten wants the books.
When do you put the slides up?
When am I going to put the slides up? Oh, you're a genius. I miss you. Yes, I shall make sure every single slide is available almost immediately.
Yeah.
So we've got some questions coming in. How do I see these things? Oh, here we go. Right. I can't answer what the cat's name is. Oh, that's too early.
Yeah.
Great. What is one single thing everyone should try tomorrow? See if you can get the day off. No, all right. Tomorrow, I would. Well, that's a really good question. Okay, so there's 3 starting points. You could either start with chaos experiments, you could start with verifications, or you could start with game days. How you navigate those 3 is down to how much buy-in you've got from your organization. So whilst technically a game day requires very little tooling, it requires a lot of people involved to do it well. So I always suggest that you could try and do a game day, but that's going to require a lot of effort on your behalf to try and get people involved. But that's the least technical challenge to start with. The other one is just a chaos experiment. Take a look at, and this for full disclosure, I'm biased on this one. Take a look at the Chaos Toolkit, see these sorts of experiments that are out there, see if you can write something simple and ask yourself one question before you do it or as you do it. What am I worried about? Is this something I could just explore to see what happens in a very safe environment? Don't start in production, please. Start in something like your own machine. You know, you can even run up the system if you can on your own system in some sort of sandbox. And just go, okay, if I automate this circumstance, what actually happens to the system? And try and pick something that where you think it will be fine, but you do have a question mark on it, because then you'll start to see the value. The reason I mentioned this as a starting point is because I've done this with a couple of organizations now where they said, well, what should I do first? And I said, well, try and write a chaos experiment for something you know will survive. Try that first. And we found that over and over again that someone has been surprised even when they thought they knew. Classic example, someone thought they knew that if a particular database, one of its nodes died, it would be fine. But it turned out they'd never seen how that database's reliability mechanisms, robustness mechanisms came into play. So it tried to survive. The database tried to survive according to all of their configuration, all of their setup for it, and it actually ended up being a lot worse than if it had tried not to survive. So that's the sort of thing where you can go, well, we think we're good for this. We've designed for this known case. You could use a chaos experiment tomorrow just to prove to yourself that it does actually respond the way you thought it did. So that might be a good place to start. It's a good question, though. Thank you. It's the leading question right now because it's the only one I've got. Okay, so no wonder. Thank you. How's going to? How do I apply some experiment to my? Oh, great. So Chaos Toolkit. So the one thing about the Chaos Toolkit is it doesn't do any chaos. It's a complete lie. It doesn't do it. The Chaos Toolkit just takes a format of an experiment and tries to execute it against the system. So if you've got a legacy system, which we'll call systems that work, if you've got a system out there like that, but it doesn't look like a cloud-based system, it doesn't look like anything that, you know, any of the hot type of systems out there, the Chaos Toolkit can be used because the Chaos Toolkit can be, you can cause chaos from the Chaos Toolkit by anything from just a shell command. You can trigger that from the Chaos Toolkit. So you can kick off a process, you can call an HTTP endpoint, and you can also call some custom Python code if you need to. So what I'm saying here is the Chaos Toolkit, by definition, is hugely extensible. So whatever system you're working with, you might need to extend it just a touch to do the thing you want to do to explore in the system you're working on. This is how I know certain large banks are using the Chaos Toolkit and the Reliability Toolkit to experiment against their COBOL-based mainframes. We don't have any drivers or extensions for those sorts of systems. They've developed those themselves. And it's not a huge amount of effort. The one thing I would say is if you are interested in doing that, if you pop onto, and if you use Slack, some people don't want to, I get it. If you do use Slack, then you can jump onto the Chaos Toolkit Slack team, and I'm always there, as is Sylvain, my co-founder, as is Grant. In fact, best of all, go and give Grant grief. That's almost very alliterative there. You know, go on there, ask lots of complicated questions about your specific system to Grant. He'll know nothing about your systems, but he'll walk you through how to create those sorts of extensions.
Hey, thanks for that, Russ.
Anytime. Okay, so if that's all the questions, we've got two. Now, Naringa, I don't want to make this hard for you, but we've only got two. So if you have a coin handy, that might work. Actually, the other thing is, do you know what? It's only two. So I'll tell you what, if both of you could ping Naringa in the team with your postal addresses, I will get 2 sets of the books to head over to you. And I'm really sorry. Yeah, no, don't worry. You'll get, that's the same person. That's cool. So yeah, Naringa, if you could get the addresses,
yeah,
I will happily send copies of the books to both people since 2 questions came in fast enough.
I think Paulus can come over. He used to be my neighbor.
Oh,
So you can send one to me. And yes, who else was? Alper. Just you can send me over the private message
One last, I'd just love to answer Alpa's last question, if that's okay. Have I got time to do that just quickly?
Yeah.
Okay, so that's a great question. Chaos and machine learning for resilience. So I know for a fact a very large company that do some fantastic work with bricks that you would use as a kid to put things together. Anonymized enough? They are doing exactly that. They're using the Chaos Toolkit, for example, to explore what happens, what is the veracity of their algorithms, their machine learning algorithms, when they experience failures. So it's totally applicable to machine learning systems. Anything you rely on, it's applicable to. If there are failure conditions, if there are situations where you think you know how it will respond, but you don't know, or for example, you might want to know whether certain alerts actually get triggered, or whether your team can interpret your observability systems appropriately and effectively and productively well enough, then you are right slap bang in the question that practicing reliability and resilience engineering is there to support. So yeah, absolutely. Chaos and ML, it's just like every other system. It's that complex because people are probably relying on it, that these sorts of things will apply and do apply. We've seen it a few times now.